All right, we're going to go ahead and graph example 3. It's y equals 1/2 to the x. I know it's an exponential function because x is in the exponent. And then, is it an exponential growth or decay? Depends on this value here. Since this number is in between 0 and 1, it's actually an exponential decay. So when I graph it, I should see that it goes down from left to right. We're going to use our graphing calculator to help us graph this one. So in order to graph it, we're going to go y, and then y equals, and then we're going to enter it in the function. So it's 1/2 raised to the x power. And then I'm going to go ahead and hit graph. Okay. I can see what the shape of it is if I hit graph. However, it is useful in order to actually look at my table and plot some numbers that will be on there. So in order to get to your table, it's above graph. So we're going to go second table. And here is the table of values. I'm going to go ahead and get a few numbers that are to the left of 0. Okay, so usually when you're graphing an exponential, you could look at to the left and right of 0. So like maybe do like -3 to 3. So we got -3, 8, -2, 4, -1, 2. So I'm going to plot those points. So -3, 8. So be careful kind of how this graph works. -2, 4, -1, 2. And then we had 0, 1/2. Then we should have 1.5, and you can hopefully keep your calculator. Yep, 1.5, and then 2.25. So 1.5, and then 2.25. And then we can sketch it. Remember, exponentials get really close to your x-axis. Sorry, it's a little hard on here, but never actually touch. And then, I'm struggling with graphing on my slate today. There we go. That does not look very smooth. So if I could graph it a little bit smoother, it'd look like that. Okay, so there is that exponential function graphed. Now what we're going to do is we're going to use that graph to figure out how you would graph the following functions. And then we're also going to state the domain and range. So I notice it is the same function except for in the exponent, it's x minus 3. So what is happening to this function is that we are taking our x's and we are shifting them to the right 3 units. Remember when it's with your x from transformations, it's always the opposite of what you would think. So this one is moved to the right, so shifted right 3 units. Okay. And then we would talk about the domain. So if I were to think about the graph, and you could also have graphed this function on your calculator, if you were to think about this graph and I were to shift it to the right 3 units, would my domain change at all? No, I would just have another function that looks the same and going all the way to the left and all the way to the right. So my domain for this one is still -infinity to infinity. Then I would also find my range. If I were to take this function and shift it to the right 3 units, my y values are still going to get really, really close to 0, but never touch, and then go all the way up to infinity. So my range is 0 to infinity, and I cannot be 0. There's an asymptote there. Okay. This next one, what is different about this one compared to this one? The initial value for the first one is a value of 1, and now it is a value of 4. Okay, so my initial value is 4 and not 1. Or y-intercept, and not 1. And so let's just maybe look at that one graphically. Does it change it at all? So I'm going to go to my y equals, and I'm going to plug a 4 in here. So you can go second, insert. Above your delete button, it says INS, which is insert. I'm going to insert the number 4 and hit enter. Okay. And then I go ahead and hit graph. So if I look at my graph, for the most part, the shape is the same, except for now we have a y-intercept of 4. But it's still going to make the same shape and get super close to y equals 0, okay, but never touch it. Okay, so we go ahead and state our domain and range for this one. The domain is still going to have the same shape going all the way to the left and all the way to the right, so it's all reals. And then my range is going to get really close to 0 and go up to infinity. All right, the last one. What has happened with this one? We look the same here, except for now we have a +5, so it's on the outside. So if it's on the outside like that, it affects our y values, and our y-axis goes up and down. So this one we're going to go ahead and move up 5 units. So we are shifted up 5 units. Okay. If I go ahead and shift up 5 units, will that change my domain and will that change my range? Okay, let's take a look at the graph. My domain, let's delete this, delete the 4. And look at it. My domain, we're still going to go all the way to the left and to the right. However, I will now have a horizontal asymptote, not at 0, but it looks like it is at 5. Okay, that moving it up 5 took it from 0 to 5. So that will affect my range. So my domain is still negative infinity to infinity. And then my range will be 5 to infinity. And we cannot equal 5. There's that asymptote there. Now C, I'm going to give you some descriptions like this, and you guys are going to go ahead and write the equation. So C, starting with the graph, y equals 1/2 to the x, write the equation of the graph that results from shifting it 1 unit left. Okay, so if you're moving left or right, that is horizontally, which affects your x values. Okay, so I got to put going left by my x value, so it'd be 1/2. And then remember, when it deals with an x value, it's always the opposite of what you would think. So it will be x plus 1. Okay. The next one, we're shifting, we're going 1 unit downward. Okay, so that's your y value, so it's got to be on the outside, not in the exponent with the x. So this would be y equals 1/2 to the x, and then to go down 1 unit, you'd subtract 1. And then lastly, if I want to reflect over my x-axis, here's my x-axis. Okay, if I'm here and I'm now going to reflect across and go to this side, I am changing my y values. So in order to reflect over the x-axis, I need to change my y values. The way we change our y values is putting a negative in front. Okay. If you wanted to reflect over the y-axis, you change your x values, so you put a negative up with your x here. Okay. So that is example 3.